Later, we're going to take a look at the problem that we proposed last time, where we have a vector field, which has a flow, which is a circle of radius 2 going clockwise. And we're going to put a curve into that vector field of radius 2 going counterclockwise. So let's find out what happens. We're going to parameterize our curve. It's a circle going counterclockwise. And we have a radius of 2. So we'll go 2 cosine of t I plus 2 sine of t times j. And this we can run from 0 to 2 pi. Then what we'll need is the dr. We'll need to know what direction the curve is going. Remember, we want to calculate, the line integral is telling us how much the vector field and the curve are going in the same direction. So we need something that tells us the direction of the curve, and that would be the derivative, so dr. So there's the velocity vector, the direction that we are headed on the curve at any point on the curve. By doing this, we've set up x of t as 2 cosine of t. And y is 2 sine of t. We need to separate out the x and the y so we can plug that into the vector field f. So our line integral we're going to evaluate the vector field at x and y. So I'll have 2 cosine of t, or sorry, 2 sine of t times I minus 2 cosine of t times j. There's the vector field evaluated. There's the vector field evaluated at every point on the curve. We find the dot product with dr, the direction of the curve. And we're going once around, so from 0 to 2 pi. Now we've set up our line integral as a simple integral. We have to calculate the dot product. We've got to figure out how much the function, the vector field f is working with or against our curve. So our dot product will still have the interval from 0 to 2 pi. I'll have multiply the I components, so minus 4 sine squared minus 4 cosine squared. And now we can see that we're going to get a negative because we have negative 4 sine squared minus 4 cosine squared. If I take the negative 4 out of there, sine squared plus cosine squared is equal to 1. So down here, we'll factor out the minus 4. And that leaves behind a sine squared plus cosine squared. And the sine squared plus cosine squared, that's all just 1. So at this point, you might be thinking, geez, Nietzsche, it seems like you're taking it easy on yourself by giving yourself an easy integral. I can see now why you dropped off that ellipse thing from yesterday and switched to this circle. And you're only correct insofar as you are absolutely correct. Like, I don't really want to do the sine squares and cosine squares. So I dropped it to a circle. Which, in terms of math, is the correct answer. We're always trying to take problems and make them easier. So here we'll just have the -4 multiplied by the length of the interval. So -4 times 2 pi. It's going to be -8. Any questions? So, as we predicted, we expected a negative value because the curve is going against the vector field at all those points. So, negative as expected. The line integral is negative, just like we expected, because the curve is pushing against the vector field. Question? If we change the direction of the circle of the curve, so C1 was a circle of radius 2 going counterclockwise starting at the point 2, 0. So what if C2 is a circle of radius 2 but going clockwise, going in the same direction as the vector field? So if C2 So that would be the thing that we want to change. If the only thing that I change, the only thing that gets changed here is that the circle is a radius 2 going, or sorry, it is a circle is going clockwise, what do we suspect would happen to the line integral? What do we suspect? What would we guess? We change the direction of the line integral to the opposite direction. What do you suspect should happen to the value of the line integral? Or at the end of the test, the second to last problem was just the previous one. We got -8 pi. And I'm like, oh, 30 seconds left. And you're like, oh shit, there's a whole nother problem. And then you look at C2 and it's just circle of radius 2 clockwise from whatever starting point around 1 time. What would you put? If you leave it blank, you're guaranteeing yourself 0 points. Even on standardized tests where they think they're giving you a penalty for guessing. Even if there's a penalty, the threat of the penalty for guessing, which is really a penalty for wrong answers, which is dick move on the test's part. What would you guess? You've got to put something. I didn't say show your calculation so you can get away with just writing an answer. Let's think about that. Go ahead. 8 pi. We're going the other direction. If we're just changing the other direction, there's nothing that should indicate that the magnitude should change. We're just changing the sign. We're going in the opposite direction. So 8 pi would be an awesome guess. If it didn't work that way, we would think there's something wrong going on here. That's how much we should suspect that we should just change the sign. Any questions? We want to be good skeptics. This is something that we can easily calculate. All we have to do is write a parameterization for a circle going the other direction. Using this particular parameterization, 2 cosine t plus 2 sine t from 0 to 2 pi, that's going counterclockwise. So we would want to verify our guess. If this was a test, we just got this back and we just got full marks for just writing 8 pi. And we're like, oh, damn, that worked. The correct thing to do would be to say, we should verify this and think about what your parameterization should be. The first parameterization I thought of when I walked in to do this problem, I said, I'll just use this parameterization for the circle going the other way. Then I thought about it for a second and I go, oh shit, that was to start at the same place. That raises a question. Does the starting point matter? What if instead of starting off at 2, 0, I wanted to start off at 0, 2 and still go clockwise or go counterclockwise? Would the starting point matter? then we need to think why or why not. What if I started off at 0, 2, went around once counterclockwise? What would change? Let's think about that. These are all questions that come up, and we can check all these, we can speculate about all these questions. We can speculate about all these questions, and then we just need to make calculations to verify our guessing, which is all we ever do. We make a guess on how something would work, and then we check to see if it will work. All we ever do is guess and check. So let's investigate the starting points. What we have is a circle of radius 2 going around once, and we've parameterized this circle the parameterization that we set up was r of t is 2 cosine t I plus 2 sine t j. The parameterization that we set up before, this is going, so this, oh, sorry, this is going counterclockwise, just like we ordered. And we went from 0 to 2 pi. Zero is starting off at, when t is equal to 0, since we're going around once, we start off at 0, and 2 pi would bring us all the way back around full circle. At the point 0, 2, this is when t is equal to pi over 2. So if we start off at the point 0, 2, that's when t is equal to pi over 2. And if we go around once from there, we'll go from 1/2 pi to 2.5 pi. So 1 pi, 2, 3, 4, 5 pi over 2. So what if instead of going from 0 to 2 pi, we just went from pi over 2 to 5 pi over 2? The endpoints only show up in the integral. So instead of integrating from 0 to 2 pi, all the function evaluated at the points on the circle, that all stays the same. The dr, that all stays the same. But instead of going from 0 to 2 pi, we're going from pi over 2 to 5 pi over 2. And we're integrating -4, a constant. So this is just going to be -4 times the length of the integral. Sorry, length of the interval. Thinking about integration, if we can make a single integral of the function 1, we get the length of the interval. Just like when we do a double integral of 1, we get the area of the region. If we do a triple integral of the function 1, we get the volume of the solid. So if I just multiply this by -4, I'll just get -4 times the length of the interval, which is still 2 pi. So in this case, starting point doesn't seem to matter. Yes. Right, it doesn't matter because it's the same path, just starting off in a different point. But we end up at the same point. We're in a closed loop. So in this case, since the curve is closed, it didn't make a difference. Question? Is everybody okay? The next thing we wanted to do was check the clockwise thing, come up with a parameterization for the curve going the other direction to make sure that we come up with an 8 pi. So there's a few options that we have. We could rewrite a new parameterization, or we could just try to run this parameterization backwards somehow. So that still leaves us with this question. How do we parameterize the clockwise curve? We know that the starting point doesn't matter. So the one that I was thinking of using this one moves the starting point, which is what I forgot when I walked in. So I said, well, we better investigate the starting point then. So if I switch from the x to 2 sine t and the y to 2 cosine t, that means when t is equal to 0, the x will start off at 0 and the y will start off at 2. So we can still go around once going from 0 to 2 pi. So this will be the same circle, but going the other direction. When t is equal to 0, So here's a parameterization that we can use for the clockwise curve. We, of course, would want to run this through our line integral, check the calculation. And see if we get 8 pi. So hopefully we'll get 8 pi. Here's the good news. This is not the only way to parameterize this clockwise curve. Here's the bad news. This is not the only way to parameterize this clockwise curve. So we have multiple ways that we can do this. And we want to make sure that they are all consistent. So we want to make sure if there are any other ways to parameterize this curve. I'm certainly heavily implying that there is another one and that I want you to think of it. So I'm going to leave that as an open question. What's another way to parameterize this curve? Here's the advantage that we have. We know what we are hoping will happen. Reversing the direction will just change the sign to a positive 8 pi. We have an integral, we got to think about what kinds of things would change the sign of our integral. What kind of simple changes can we make to our integral that would just change the sign of the result? What other options? See how committed we are to this change the sign idea. Let's change another thing. Suppose C3 is going to be a circle of radius 3, going back to counterclockwise once around. Let's think about what changes would happen to the parameterization. So here's our R3 of t. We know we can parameterize a circle of radius r just by r cosine t and r sine t. Our circle of radius 2 put a -4 as the thing that we're going to integrate. What we're going to get here, since r prime In this case, when we find the dot product of f dot this dr, f is going to have 3 for coefficients, and the dr3 will have also 3 for coefficients. So just tracking the changes that we had in the previous problem, our integral around C3 of f dot dr we should expect all the same things to happen. We're still going to be integrating from 0 to 2 pi. But now we expect we're going to be integrating a -9 dt. Before we had 4 times the length of the interval, or -4 times length of the interval. Now we have -9 times length of the interval. We change all those previous 2's to 3's. Instead of a -4 in our integral, we'll have a -9 in our integral. Question? How's everybody okay? And then finally, our C4. I know there were 6 of them yesterday. But you can always count on me. If I assign y'all 6 problems, I'm definitely going to do like no more than maybe 4. So C4. This one might require some more calculation. Or C4 is the ellipse. But when we had a circle of radius 2, our line integral returned -8. A circle of radius 3 give us a -18. So we can speculate what should happen if we try to take a combination of those two. So our suspicion might suggest, we might be suspicious, and we might think this should be something between -8 pi and -18 pi, since our path is like in between those two. So that might be our speculation. We should expect something between -8 pi and -18 pi, since this ellipse is kind of in between those two circles, circle of radius 2 and our circle of radius 3. Oh. Changes one thing, and see the progression of the changes. Any question? Comment? Any thoughts? So the idea is to look at a concept, think about what that concept means, and then establish a progression of problems that will help us explore these ideas. And that's what these for problems work. Start with something that's nice and straightforward. A flow that's a circle, a curve that's a circle. What happens if we change direction? What happens if we change our starting point? That didn't seem to matter. Changing direction, we should expect to just reverse the sign. If we just think in terms of the fundamental theorem, instead of doing F at Q minus F at P, changing the direction is just going to switch to F at P minus F at Q. That's just going to change the sign. A minus B is the opposite of B minus A. So now we've got this ellipse. It's somewhere in between the two circles, kind of a combination of those. So we should expect something between -8 pi and -18 pi. But here's where we're going to have some mix of sines and cosines that aren't going to cancel out. And so that is what I'm going to bail on doing the calculation and leave it all up to you. So if you can guess, which is the question I am not going to be answering today. Mainly because there's more work involved in this question. And so I'm going to have y'all do it instead of doing it myself. Questions? Comment? So tomorrow, tell me what the integral over C4 of f dot dr is. Verify it is indeed between -18 pi and -8 pi. Or if it's not in between those two, why not? That would make us suspicious of. That would reveal something that we possibly don't understand about what's going on with these line integrals. Good question. It'd be really useful to have some kind of application that we can get our hands on and think about. Like car going faster, cover more ground and things like that. But that's a physics question. I don't know physics. This is a math class. We're studying how the math works. So. Any questions? Comments? Deep thoughts? All right, that's going to do it for today. I will see you all on tomorrow. Everybody have a good day and thanks for playing.